Hi, I'm Grant.
And I'm Jacob.
And today we'll be presenting the laws of sines and cosines. You can use the laws of sines and cosines to solve a triangle when you've got two sides and one angle, or all sides and no angle. To prove this, let's look at an example.
The triangle that we're looking at has two side lengths and an angle between them. The first side length being 9, the second one being 17, and the angle joining them 73 degrees. The law of cosines is set up like this. C squared is equal to a squared plus b squared minus 2ab times the cosine of c.
Now, for those of you wondering, we can't yet use the law of sines because we don't have any matching pairs, say between this angle between the two and the opposite side. But once we solve for the side opposite the 73 degree angle, we can use the law of sines to find the other two angles.
So now let's plug in some values. So c squared is what we're going to be solving for, so we're just simply going to leave it as that. And a squared is going to be the 9 plus the 17, which is the b squared, that other side length, minus 2 times 9 times 17 times the cosine of angle C, which we said right here was 73 degrees. Now when we multiply and simplify a little bit, we get 370 minus all of this value, which is equal to 89.466. When we further simplify, we get c squared equal to 280.534. Taking the square root of that, we get a final side length measure of 16.75.
We now have a matching pair of angle C and side C. So we can use the law of sines to find the other two angles. Here's how it looks. Sine of A over A is equal to sine of B over B, which is equal to sine of C over C. The cool thing about the law of sines is that this can be flipped, where A over sine A is equal to B over sine B, which is equal to C over sine C. So, because we have a matching pair of a side of 16.75 and an angle of 73 degrees, let's plug a quick tip here. If you're solving for the angle, it's best to put the angle on top. So we've got sine of C, which is equal to the sine of 73 degrees, over 16.75 is equal to the sine of angle A, right here, over 9. Now, sine of 73 degrees over 16.75 is equal to 0.057. So 0.057 equals sine of A over 9. But because we're solving for A, we have to get on its own side, so multiply both sides by 9, and we get sine of A equals 0.51, so sine of A equals 0.51. Now, to solve for angle A, we have to find the arc sine. It can also be written as sine to the negative first power of 0.51, and that is equal to 30.863, which we can round to 30.9. So angle A is equal to 30.9. But we're not done quite yet, even though we can sub this into our equation. Rather than use the law of sines to calculate our final angle, instead we can use some simple addition. 180 minus these two angles combined should give us the value of angle B. 73 plus 30.9 is equal to 103.9. 180 minus 103.9 is equal to 76.1. So our final angle is equal to 76.1. And we can see that here with all our final values. We thank you for your time, and that is how you solve a triangle using the laws of sines and cosines and the 180-degree angle theorem.